Before you continue with this video, there is a starter worksheet if you have not already done that. So if you complete that first before carrying on with this video. There is also a worksheet to accompany this video so that you can be filling in the key parts that you will need to be learning as we go through this video. Neutralization. We first want to look at what this word neutralization actually means. So when we're talking about neutralizing something, we're talking about counterbalancing, so making something neutral, making it ineffective. So we've talked previously about acids and alkalis being corrosive in nature. So once we have neutralized our acids and alkalis, then that neutral solution isn't corrosive, it's safer for us to handle. And that's one of the advantages of us carrying out neutralization reactions. In the incident, for example, of an acid spill, we're going to need to make that solution safe for us to clean up. And one way to do that is through neutralization. So the way in which we can make a neutral solution, last lesson we've looked previously at where the acids, alkalis and neutral lie on the pH scale. So the neutral position lies between the acids and the alkalis. And so we can use acids to neutralize alkalis and vice versa. We can use alkalis to neutralize acids. Our H particles that our acids release and our OH particles that our alkalis release, they react together. Now, when H and OH come together, and we'll look at this in a moment, we actually make water, and water is a neutral substance that we are familiar with. So when we are adding alkali, so here we've got an acid to start with. I've included pH scale using universal indicator at the bottom for reference. So we're starting off with a pH of 1 and we move to a pH of 3 and then to a pH of 7. So our pH is increasing as we are adding our alkali, because remember our alkali has a very high pH, and so as we add it to our acid it allows us to move towards that neutral position away from our acid. And similarly we can do the same thing to our alkali, so starting off with our pH around 14, moving to 10 and eventually to our neutral position of 7. So here our pH has decreased, going from our alkali to our neutral. So can you please, in your worksheet where you've got this set up, can you please complete the sentences by filling in the gap, thinking about what solution you're adding and then what is happening to the pH as we go from either the acid or the alkali that we've got here to our neutral at our end. So thinking about whether it's increasing in pH or decreasing. And when we're thinking about that, we're thinking about it numerically. So 1 to 14 is increasing in numerical value, whereas 14 to 1 is decreasing in numerical value. So pause the video whilst you have a go at that. So these H particles that our acid are releasing react with our OH particles that our alkali release. And they then bond to form our water, leaving the remainder, the X, whatever that might be, and whatever metal we are using in our alkali to react to make MX. And this MX here is a salt, so something such as sodium chloride. So in your worksheet you now have a word and symbol equation to fill in. So pause the video whilst you fill in both the word and symbol equation for this neutralization reaction. Okay, so considering all of that, using litmus tests, so thinking back to last lesson, we saw that red litmus goes to blue in alkali, it will stay red in acid, whereas our blue litmus becomes red litmus in acid, and in neutral they are both going to remain the same. So thinking back to the first lesson, which one's acid and alkalis and which one's neutral, I have drawn a table for you on the worksheet so that you can fill this in. So these are the options I have tried to indicate on that table. Is I want you to be telling me what would happen to the red litmus and what would happen to the blue litmus. So you have 4 choices. They can be used more than once in your table. So having a think about what happens to our blue litmus and what happens to our red litmus in each of these. So pause the video while you have a go at that. So as we started to see when we were doing the introduction to the neutralization at the beginning, we saw how we can go from, if we were using universal indicator, red to green when we neutralize our acids, and from purple to green. And so this was an example of how we could use, say, universal indicator to identify the end point of neutralization. So this end point is the point at which the amount of hydrogen particles are equal to the amount of OH particles, because this allows us to make the water molecules H2O, because we need one H for every OH in order to make the H2O molecule. So at the end point, we have equal amounts of H equal to the amount of OH. We don't have an excess or too much of either one of those, because then that solution would be either acidic or alkali. So on your worksheet, there is a part to fill in about how indicators are used. So thinking about my explanations, write these into your own words. If you pause the video whilst you do this. So now on your worksheet you have a copy of this question. You don't need to copy it because you already have it on your worksheet. So completing the table to show what the beaker, so we're talking about these beakers in each case, at each stage of the experiment. So to start with, we only have hydrochloric acid in this beaker. So even though we've got this diagram ready to pour into the sodium hydroxide solution, at the start we only have hydrochloric acid. During the midway, you can see the level has increased, and so we now do have both the sodium hydroxide and the hydrochloric acid in here. We should also make the assumption that these react straight away. So sodium hydroxide and hydrochloric acid, they react to form sodium chloride and water as indicated in this substance column. So these are our reactants at the top, and these are our products. And then at the end point, so remember this is the point at which we reach neutral. What is going to be present during that end point? Then want you to describe what the pH changes are during the reaction. So the pH of the hydrochloric acid is 1, so that's at the start. What's our pH going to be at the end point when it's neutral? And therefore we can describe the change in pH that's happening midway. But thinking about, is it increasing or decreasing to what that end point pH is? So pause the video while you have a go at that. So this pH scale has been annotated with different substances. So we just saw in that previous question hydrochloric acid having a pH of 1, and sodium hydroxide, which was present in that question, actually has a pH of 14. So right at the opposite ends of our pH scale. But we've also included some other substances which we come across every day. Hydrochloric acid is actually the type of acid that we find in our stomach, and they've said here sodium hydroxide can be used as oven cleaner. We've seen previously that lemon juice and vinegar are acids, Orange juice I also said was acidic because we said all citrus fruits, so lemons, oranges, limes, grapefruits, etc. are all acidic. We talked about tea previously, but actually also coffee is slightly acidic, so that's due to the caffeine that is in coffee. And then rainwater. This is slightly acidic, and you might have heard of acid rain, and that is because of the gases that get dissolved in the water clouds, and therefore make that water slightly acidic because it has small quantities of acids that have been dissolved, and that's as a result of pollution, so gases such as nitrogen oxides and sulfur dioxides that have been produced. They then dissolve in the water in the clouds, making the rainwater that slightly bit acidic. So pure water, of course, comes at 7. Baking soda, so this is your bicarbonate of soda that you might use in cooking. It's what makes cakes rise, and we'll talk about that later on in the course of these lessons. Milk of magnesia, soap, so something that you'd use every day, and then washing soda, so this is your washing powders and washing chemicals that you'd use to clean clothes. So lots of everyday substances here, and we can look at how we can use these in order to neutralise each other. So one particular use of neutralisation can be a home remedy for bee stings. So bee stings are acidic and have a pH of around pH 3. So out of these 4 options, which do you think would be the most suitable in order to neutralise that bee sting? So pause the video while you have a think. So it is bicarbonate of soda. So pH of 9, if we think about our pH scale, we've got 7, we've got 3, and we've got 9. So they're pretty much similar position away from each other. pH of 9 is the only alkali that was given in that in those options. So if we jump back, it's the only alkali present. However, wasp stings are alkaline. So if you are stung by something and you don't know whether it was a wasp or a bee, I would not recommend that you do a home remedy because you might make it worse for yourself. As you've just seen, bees are acidic, whereas wasps are alkaline, and therefore the treatment that you need to use is going to be different. So have a think about what you would use in order to treat a wasp sting. Pause the video while you have a think. And it is black coffee, so pH of 5. Now this is more favourable compared to our lemon juice because that lemon juice is slightly too acidic. It's going to push it the other way. Okay, so next one is about indigestion. So this is what happens when you have too much acid being produced in your stomach. It's often referred to as heartburn. And this acid, having too much of it, you might also come across it being acid reflux. So hydrochloric acid, as I said when we were looking at our examples, has a pH of around 1. So out of these 4 options, which is going to be the most effective at neutralising this hydrochloric acid? So pause the video whilst you have a think. And of course it's going to be our antacids, so ant like anti, which means against. So it opposes the acid, so the clues in the name there. This is an example of an indigestion tablet, and you can see here they've called it heartburn as well as indigestion, because heartburn is the pain that you feel as a result of indigestion. So do you think that toothpaste is an acid or an alkali? And once you've decided, why do you think that? So pause the video whilst you have a think about that. So the answer to this, if we consider those different everyday substances that we consider acids, so we talked about our citrus fruits, we talked about vinegar, we talked about tea and coffee. But if we think about the kind of foods that were everyday alkalis, there weren't really too many. So bicarbonate of soda, we could argue because we use it in baking. But other than that, there aren't actually very many alkalis that we would ingest. So because lots of our foods and drinks are acidic, the purpose of our toothpaste is to neutralise acids, and therefore it must be an alkali. So it helps prevent the tooth decay because acids are building up around our teeth during the day from the food and drink that we eat. Okay, so finally, 4 questions thinking about those uses that we've just discussed for you to complete on your worksheet. Thank you all for watching. Any questions, as always, please either email me or message me on Teams. See you all next lesson. Thank you.